In this video, we are going to be talking about rational expressions. Now, a rational expression is basically a fancy way of saying a fraction, which could look something like this: x plus 2 over x squared minus 3. That is a rational expression or a fraction. And so in this video, we are going to be addressing simplifying, multiplying, dividing, adding, and subtracting rational expressions. So first off, let's start by simplifying. With our first problem, we want to simplify 21 over 45 by reducing it to its lowest terms. And now how we're going to do that is we're going to factor both the numerator and the denominator. And so if we factor 21, that can be rewritten as 7 times 3, and 45 can be factored as 5 times 3 times 3. And so when we rewrite this expression in its rational form, we would have 7 times 3 over 5 times 3 times 3. And so now we can cancel out a 3 on the numerator and denominator, which would leave us with a final simplified version of 7 over 15. Now let's address a more complicated problem. We're going to follow the same step and factor both the numerator and the denominator. So if we factored 3x plus 6 over x squared plus 4x plus 4, we would then have 3 times x plus 2 over x plus 2 times x plus 2. And again, we can cancel both in our numerator and the denominator in x plus 2, which would leave us with a simplified version of 3 over x plus 2. So this portion wraps up simplifying rational expressions. Next, let's address multiplying and dividing. Now with multiplying, it is pretty straightforward. You get to multiply straight across with your fractions. So we can multiply our 4 times 2 and our 3 times 5 in this first example. And that would look like this. And when we simplify that, we would have 8 over 15. And now when you're dividing rational expressions, so in this case, we have a 4 over 5 divided by 2 over 3, we are going to multiply by the reciprocal of our denominator. So in this case, our denominator is 2 over 3. The reciprocal of 2 over 3 would be 3 over 2. And so we would have 4 over 5 times 3 over 2, and then like above, we can multiply straight across, and we would have 12 over 10 or 6 over 5. And so now let's address a more complicated version. So we have x squared plus x over x plus 4, and that is over x plus 1 over x squared minus 16. So we're going to do the same thing where we're going to take the reciprocal of the rational expression that is on the bottom. And so we would multiply by x squared minus 16 over x plus 2. And now when you do that, we would have x squared plus x times x squared minus 16, which is over x plus 4 times x plus 1. And now we can't stop there because we have more that we can factor. We can factor in the numerator our x squared plus x as well as our x squared minus 16. And so if we did that, we would have x times x plus 1 times x plus 4 times x minus 4. And that is all over x plus 4 over x plus 1. And now we have a lot we can cancel out here, which I think is the fun part. We can cancel out an x plus 1 on both numerator and denominator, and an x plus 4 on both the numerator and the denominator, which would leave us with a final simplified answer of x times x minus 4. So that wraps up multiplying and dividing. Now let's talk about subtracting and adding. So with our first example, we have 7 over 6 minus 4 over 15. Now what we want to do is we want to find the common denominator. And the common denominator is an expression that both denominators divide into. But more helpful for us, we want to find the least common denominator, which is the smallest expression that both denominators divide into. So let's find both of those to show how that works. So if we wanted to find the common denominator, we would just multiply both denominators of our fractions here. So we would just multiply 6 times 15. That would be the common denominator, 90. But if we wanted to find the least common denominator, we would factor both of these values. So we would factor 6 into 2 times 3, and then we would factor 15 into 3 times 5. And now out of those two factors, we are going to pull out the common ones. So we have 2, and we have 3, and we have 3 again, and we have 5. So we don't need to take 3 twice, so we're only going to take 3 once. So we have a 2, and we have a 3, and we have a 5. Those are the different possible factors. And so when we pull that out, we would multiply those 3 values against each other, which would equal 30. And so that is how you would find your least common denominator. Now you want to make it so both of these fractions have a denominator of 30. And so how we're going to do that is by using multiplication. So 6 times what value would equal 30? 6 times 5 is equal to 30. So we're going to multiply both the numerator and denominator of 7 over 6 by 5 over 5. And then similarly, with 4 over 15, we would need to multiply the equation by 2 on both the numerator and denominator. And so when we simplify this, it would be equal to 35 over 30 minus 8 over 30. And now we just simplify straight across, and we'd have 27 over 30. And now we can't stop there because that can be simplified further. We can factor 27 as 3 times 3 times 3, and 30 can be factored as 2 times 3 times 5. And so now we can cancel out a 3 in both the numerator and the denominator, which means our final simplified answer would be 9 over 15. And so it would also work if you just used the common denominator, if you found that easier, but it gets harder because you're dealing with larger numbers. The pro of using the least common denominator is that we only needed to multiply our solution to be equal to 30, which is easier than trying to get it to 90. So now let's go ahead and work on a more complicated problem. So again, we're going to find the least common denominator. And in this case, we are going to factor 2x plus 2, which would be equal to 2 times x plus 1. And then we're going to factor x squared minus 1, which would be equal to x plus 1 times x minus 1. So again, we have an x plus 1 twice, so we don't need 2 of those. So we would have 2 times x plus 1 times x minus 1. And that would be the least common denominator. So now we are going to multiply these two fractions so that their denominators are the same. So with our first one, what we are missing is an x minus 1. Right? So we're going to multiply both the numerator and the denominator by an x minus 1. And then with our second fraction here, 5 over x squared minus 1, we are missing a 2 value, because x squared minus 1 can be factored as x plus 1 and x minus 1. So we're going to multiply both the numerator and the denominator by 2. And so if we multiply all of that out, we would get 3 times x minus 1 over 2 times x plus 1 times x minus 1 plus 5 times 2 over the same denominator. And so if we do addition straight across, we would get 3x minus 3 plus 10 over 2 times x plus 1 times x minus 1. And if we simplify our negative 3 and 10, we would get 3x plus 7 over 2 times x plus 1 times x minus 1. Now that is simplified. Some people would prefer to multiply out the denominator, but that is up to your preference. So that wraps up rational expressions. So just to wrap up, we talked about simplifying, multiplying, dividing, and adding fractions